Today's lecture is on quantitative inheritance. Under quantitative inheritance, we'll see the population genetics. In a population genetics, we'll see the Hardy-Weinbergs law. It is a fundamental law of population genetics and provides the basic for studying the Mendelian populations. This law was independently developed by Hardy in 1908 in England and Weinbergs in 1909 in Germany. The law states that the gene and genotypic frequencies in a Mendelian population remains constant generation after generation if there is no effect of selection, migration, mutation on random genetic drift. The frequencies of three genotypes for locus with two alleles, say capital A and small a, would be p square as capital A twice pq as a capital A small a and q square as a small a, where the p indicates the frequency of capital A and q indicates the frequency of small allele. In a population and the sum p and q is a 1, that means p plus q is equal to 1. Such a population would at equilibrium, since the genotypic frequencies would stable, that is there is a no change from one generation to the next generation. This equilibrium is known as Hardy-Weinberg's equilibrium. A population said to be equilibrium when the frequencies of three genotypes, that is the capital A, capital A, small a, small a, are p square twice pq and q square respectively. Night one and second one, that is the free random mating. There should be a free random mating among the individuals of Mendelian population. There should be any mutation, migration and random genetic drift. For example, let us consider the Mendelian population with P, that is the frequency of dominant allele A, and Q is the frequency of recessive allele small a. Then the frequency percentage is 100 and P plus Q is equal to 1. If the population contains capital A type of allele with 70% and small a type of allele with 30%, then the percentage frequency P of A is equal to 0.7 and percentage frequency Q of A is equal to 0.3. In the next generation, the distribution of genotype and gene frequencies can be represented as follows. That is the p square plus twice pq plus q square is equal to 1. And now representing in a checkers board, p of a, that is the 0.7, q of a, that is the 0.3, and when we can make the selfing, then the p square is equal to 0.49, pq is equal to 0.21, and pq is equal to 0.21, and q square is equal to 0.09. In this new generation, the frequency of allele is percentage frequency p of a is equal to p square plus half twice pq is equal to 0.049 plus 0.21 is equal to 0.70%. The frequency of q of a is equal to q square plus half pq is equal to 0.09 plus 0.21 is equal to 0.30%. That means this indicates that the gene frequency is remains constant in a generation. That is, the genetic equilibrium is maintained. Thank you.